kaashyap Envergy creates infrastructures in the realms of environment and energy. kaashyap Envergy provides solutions to capture energy as well as crystal clear water from the high-strength organic wastewaters generated in sugar factories, palm oil mills and paper mills. A biogas plant set up in Malaysia by kaashyap Envergy is an accomplished endeavour in achieving the company's objectives.
The project is unique in design, as on one hand, the Palm Oil Mill Effluent is treated to bring down pollution load and convert the wastewater to crystal clear water, and on the other, to generate non-conventional and renewable energy in the form of methane-rich biogas, from which power is produced. The palm oil mill is expected to generate about 500 cubic meters per day of raw wastewater, POME, which is subjected to certain pre-treatment and stored in an equalization tank. The equalization tank has an optimum volume to take care of fluctuations in the generation of raw wastewater. The raw wastewater is pumped thereafter from the equalization tank to the top of anaerobic reactor 1 and anaerobic reactor 2 simultaneously. The anaerobic reactor is a specially designed double digester system with twin lamellar clarifiers and a common biogas holder. The raw wastewater entering at the rooftop of the anaerobic reactor 1 and reactor 2 is pushed down through a vertical hollow pipe by a central agitator working like a ship impeller. The raw wastewater entering into the digester is thereby mixed completely with the contents of the reactors. In order to provide further mixing and optimum contact with the large population of bacteria inside the reactor, the digester content recycling pumps carry out the recycling process. The overflow from the anaerobic reactors is passed into the lamellar clarifier to capture and recycle back active bacteria escaping out of the reactors. A degasser installed between the anaerobic reactor and the lamellar clarifier expels dissolved gases, if any, present in the overflow from the reactor to facilitate smooth settling in the lamellar clarifiers. After treatment in the anaerobic digester, the raw wastewater is collected in a sump for further treatment in EcoCar. In EcoCar, the partially treated wastewater is completely disintegrated and the solids are removed in a tertiary lamellar clarifier. The overflow from the tertiary lamellar clarifier is taken to a treated water sump. This treated water from EcoCar is crystal clear water, devoid of all color and odor. This treated water may be recycled back into industry, or it may be used for irrigation. Hence, this is a zero-discharge system protecting the environment. The biogas generated in the reactor is collected in the inside of the reactor's hemispherical-shaped roof. The biogas collected in the digester roof is taken to the gas holder, which acts as an intermediate storage tank as well as a safety device. The gas holder consists of a stationary outer shell and vertically floating inner shell. As the biogas flows in from reactors and gets accumulated in the gas holder, then the floating drum gets lifted vertically up, and simultaneously the biogas is also drawn out of the gas holder by a biogas blower, which brings down the floating drum. As both of these activities happen simultaneously, equilibrium is reached, and the floating drum hangs at a particular height, properly guided through the guide frame. Limit switches are provided which trip the biogas blower when the floating drum reaches certain top and bottom design levels in its vertical movement. The biogas blower draws out the biogas from gas holder and transfers it to the biogas scrubbing unit. The biogas scrubber removes hydrogen sulfide from the biogas and therefore protects the biogas engine from corrosion. The scrubbed gas is further transferred to a gas engine, where it is utilized as a fuel to generate power. The excess biogas, when not used by the biogas engine for power generation, is flared off to protect the environment.